Our next section is going to look at 4 generations of, you could say, modern computers, 4 generations of electric computers, electronic computers. So we're going to turn the page and look at how things have progressed in the last 100 years to get where we are today. And they all began with the first generation built in the 1930s into the 40s, was the vacuum tube. You may not be familiar with a vacuum tube. I know from this picture you can't tell. It's about 6 inches in size, and it basically does the same thing as a relay switch. It basically does the same thing as those punch cards. It holds a value. It holds a binary value. Instead of a relay mechanically moving that device up and down, mechanically, you can see the different, get my cursor going here. There we go. You can see the different pins here where you could send a control signal in, just like the relay had, to turn on or off other signals. So just understand that this vacuum tube was doing the exactly same thing as a relay, except much faster. There's no moving parts here. That means less failure, faster, quieter, less power than to mechanically turn on and off those magnets. Vacuum tubes, let me kind of take a break from computers. Vacuum tubes are also used in other industries besides computers, as we saw in the punch cards. One very common place here is if you ever saw a large television from 1970s, maybe the early 80s, it was full of vacuum tubes. That's why those were so large. Part of it is because they had a cathode ray tube. That's a different topic, but that's another reason this physical picture here was probably about 18 inches deep. But all the controls that turn on volume and channels were all using vacuum tubes. So if you ever see one in a flea market, look in the back of it, and you can see vacuum tubes. Now, there's another industry, and to my knowledge, there's only one industry still in this modern era still using vacuum tubes. And it's not because they have to, because they want to. I'm going to show you an image and see if you can figure out what industry is still using vacuum tubes. I'm going to let you look at this image for a moment and see if you can figure out. And I'll give you a hint. In the back right-hand corner, you should see a guitar. So some people still like to recreate the sound of guitar amplifiers from 30 and 40 years ago when they were using vacuum tubes. So you will still see to today some hobbyists, people who are creating or buying guitar amplifiers that still like to use vacuum tubes because it gives them a similar sound that they like from decades ago. But to my knowledge, they're the only ones who are using vacuum tubes. Now, let's go back to the world of computers, and let's look at a computer. I know there's a lot of text on the screen. I'm going to read each part of this and what you need to know slowly. But this computer is called the ENIAC. It actually is an acronym that stands for Electronic Numerical Integrator and Computer. No one calls it that. So just put down in your notes, ENIAC. The ENIAC is the first programmable general purpose electronic digital computer. And let me pause there for a moment. All that means is, well, we know what digital means. It means it's using binary values. Electronic means it's not using relays. It's only using vacuum tubes. And that programmable general purpose means it can do more than one thing. To give you an example of a device that's not programmable would be, let's say, gas pump. Yes, there's some electronics in there and maybe some computer parts, but a gas pump it just does one thing. It pumps gas. It keeps track of how much gas. It turns on and off the switch that allows the gas to come out and tabulates a bill, but that's not reprogrammable. You would not repurpose a gas pump to do some other task. So a computer needs to be programmable, general purpose, meaning it can do different types of games, different types of applications, does different things. It was developed during World War II. You will find that during times of war, technology is often pushed faster because there is a great need, and so more money and more research is given to technology needs, sometimes in times of war, and this was the case. It was actually finished right at the end of World War II, and specifically it was designed actually to calculate missile trajectories. So if the military fired a missile, they need to calculate many different things about physics and the weather, air pressure, the curvature of the earth. A lot of different mathematical variations go into the landing of this missile, and they could actually use this to calculate that. So just to clarify, only one of these was built. This is not like an iPhone where they developed and they created one and they mass produced it. There was only one ENIAC ever built. I believe it was in the Pittsburgh area where they built this. There are still parts of this ENIAC. They took it apart after 15 or so years of it being used, and part of it is actually in the Smithsonian Museum in Washington, D.C. So you can see, parts of it. It did use vacuum tubes, specifically 17,000 vacuum tubes. So you can see why it needed an entire room, because that's a lot of vacuum tubes. Now, as you can imagine, with 17,000 vacuum tubes, they would burn out. Just like a light bulb, if they overheated or something malfunctioned, it would have to be constantly be replaced. So you had people's full-time job was to check, monitor, and replace these vacuum tubes. High cost, because they were pulling a lot of current to run these. It did have high cost, not as high as the relay switches, but high cost. High temperatures, because it produced a lot of heat. And it just physically was a large computer. I say a lot of these negatives because we're going to see some dramatic changes in the next generation that specifically goes to fix some of the problems with the ENIAC. But for now, this is the most powerful computer they've ever built. In fact, if you go down here, it had the speed on the order of 1,000 times faster than that of the electromechanical machines, like the relays we just looked at. The combination of speed and programmability allowed for thousands more calculations for problems, as the ENIAC calculated a trajectory in 30 seconds that took a human 20 hours. So you can see how this is just a huge game changer for, in this case, the U.S. military. In a few decades, the business world would benefit from this new technology, and then eventually into the home, which is generally the last place to benefit from new technology. So first generation computer, just to recap what you need to know. First generation used vacuum tubes. Vacuum tubes store ones and zeros just like the relays and the punch cards. The ENIAC was the first computer built using only vacuum tubes. It was built for World War II by the United States, and it had 17,000 vacuum tubes that had several problems with cost and temperature and physical side. It was also much faster. So that is the ENIAC, and that's generation 1. There were other computers in generation 1. So there was dozens of other computers built by some by the government, some by private corporations, but the ENIAC is the first and by far the most well-known computer in generation 1. So we want to make sure you know about that one.